Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet with me, Richard here. Yes, today we're looking at this question. It's a grade 10 question. It says that define the term chemical bond. Okay. Yeah, what is it? What is chemical bond? Okay. Chemical bond is defined as attraction or mutual attraction between two atoms, resulting from simultaneous attraction between nuclei or positive nuclei of one atom and the outermost electrons of another atom. We have to know that inside the nucleus we have protons, which makes the nucleus positive. And outside the nucleus, we find electrons. So that attraction resulting from the positive nucleus and negative electrons of another atom is what we call chemical bond. Yeah. Then we come to this question. It says that consider the element below. This is chlorine, sodium, carbon, oxygen. Okay, and the question says draw Lewis dot diagram of each. Okay, yes, let us start with chlorine. Okay, what are we doing here? We are drawing Lewis dot diagram. The question is, what is it? Okay, Lewis diagram represents the symbol of an atom with the outermost electrons distributed around it. The question at hand is, how do we get the number of electrons we distribute? Okay, there are two approaches to determining the number of electrons we distribute. The first approach, we can use what we call electronic configuration. What is electronic configuration? Is the distribution of the number of electrons across the energy levels. So we can use that. So in this case, we use what we call atomic number, because atomic number reflects the number of electrons in an atom, because the number of electrons in an atom are equal to the number of protons. So if atomic number represents number of protons, so it represents number of electrons. Another approach, we can use the group number. Because what are we trying to do here? We are trying to find out how we can obtain the number of electrons we are going to distribute around chlorine. If we use the electronic configuration, you need the atomic number. And the atomic number for chlorine is 17. So how do we get it? This is what we do. We know that the first orbital, the first energy level, is 1s and takes up a maximum of 2. The second energy level is 2, so it's 2s taking up 2, and 2p taking up a maximum of 6. And when you do the count here, we'll have already 10 electrons distributed. So we go to the third energy level, which is 3s, 2, and 3. So these are 12, 3p, 5. So what you have here is the electronic configuration of chlorine. And here we have the number of electrons in outermost shell, which we call valence electrons. So it's these valence electrons which we distribute. Or alternatively, some people just go straight to the group number. Chlorine belongs to group 17, and group 17 has 7 valence electrons, or 7 electrons in outermost energy level. So in other words, group 17 has 7 valence electrons. So either way, you have the 7. And what do you do with the 7? This is what we do. You have your symbol of the element, and next you distribute the 7 electrons around. Okay, according to Lewis, each corner at first takes 1. Okay, then there are 4 corners. After that, you start pairing. So there are 5, there are 6, and there are 7. Yeah. So what we observe here is the Lewis dot diagram of chlorine. Yeah. Next is sodium. Okay. With sodium, if you look at its electronic configuration, you have to realize that sodium has 11 as the atomic number. And what do? We use 11 to find our electron configuration, which is going to be 1s2. That's the first energy level. Then we got the second one, which has 2s2 and 2p6. These are 10. So we are remaining with 1. So the 1 goes to the third energy level, and it will start with 3s, and then we put 1. Okay. Then we come to the other approach. The other approach, we look at the group number. So sodium group belongs to group 1. And group 1 has 1 valence electrons. And so the 2 gives us the same. So either way, if you are using the electron configuration or the group number, what you have is 1 valence electron to distribute. So what is the next step? Next step is to have our symbol. So what is the next step? The next step is to have our symbol, which is sodium. And then you put your single valence electron. So what you have here is the Lewis dot diagram of sodium. Yeah, next is carbon. Okay. Yes, if we use the electron configuration approach, we know that carbon has 6 as the atomic number. And if that is true, then what do? We write the electron configuration of carbon, which starts with 1, s2. That's the first energy level. Then we go to the second energy level, which is 2. So it's going to be 2s2. These are already 4. Then the next one is going to be 2p2. That is it. So, like we said, what we have here are the valence electrons. And these are the one we distribute around the atom. Or alternatively, you can just go to the group of carbon. Carbon belongs to group group 14. And group 14 has 4 valence electrons. So either way, if you use this approach or this one, it comes to the same thing. We have 4 valence electrons to distribute around carbon. So what do? You have your carbon, and then you distribute the valence electrons around it. We have one corner taking up that, another one here, another one here, another one here. Yeah, that is it. So what we have here is the Lewis dot diagram of carbon. Yeah, then lastly, we are coming to oxygen. Okay, we can use the same 2 approaches. The first one is electronic configuration, which we get from atomic number. And what is the atomic number of oxygen? It is what is the atomic number of oxygen? It is 8. So we have 8 electrons to distribute across the energy levels. We have the first one, which takes up a maximum of 2. Then we got the second energy level, which is 2s2. Those are already 4. Then we got 2p. We are remaining with 4, which comes here. So from this configuration, what do we see? We are seeing that we have 6 valence electrons. Or alternatively, you can just go to the group to which oxygen belongs. Oxygen belongs to group 16. And group 16 has 6 valence electrons. Either way, if you are using this one or this one, we are ending up with 6 valence electrons, which we are going to distribute around oxygen. So next step is to have oxygen as our symbol, and then we distribute the electrons around it. There are 6. According to Lewis, each corner first takes up 1. Okay, those are already 4. Then next we start pairing. This is 5 and this is 6. Yes. So what you see here is the Lewis dot diagram of oxygen. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Survivability, with me, Richard, here. Yes, we appreciate your time. We urge you to subscribe, to comment, to like, to share. Yes, we believe you'll not regret. See you next time. Bye-bye.